All right, everyone, welcome back to another lecture of Comp 426, Modern Web Programming. This is lecture 18. Glad to have you all here on this rainy day. I know it probably took a little bit more effort today to get here, so I appreciate it. We're going to get started with some announcements. So if this will connect, and if not, that's fine. Let's see. Nothing is clicking anymore. There we go. All right, so the first announcement, apologies. So if you noticed, if you're looking for a lecture video for last week, what actually happened is about 15 or 20 minutes in, the mic died. So there is pretty much 55 minutes worth of no audio at all, which I don't think is very useful. So what I did do is I linked here last semester's lecture video. It's approximately the same. There are a few differences in how we manage the database, but you can the main content regarding WebSockets and real-time is still the same. So I would look at that if you need to. You can disregard any differences you may see. And so hopefully from here on out, all of the devices I've tested should be connected so that we don't have this issue again. Another note is midterm is next class, which you all have already seen. The information regarding that has been out on the website. There were practice questions already there for the web app architecture section, another practice assignment in grade scope for React, and then also some details about kind of the motivation questions and et cetera that are good to practice there. So keynote here, do not stress. I know I've found out throughout this week how much has been going on in other classes. I think we're hitting the pain point of the semester where everybody is kind of doing things at the same time, which is very unfortunate. So I'll say here, the exam's only 10% of the grade, right? You have a lot of the resources already to study for it. And also in this class, for example, A01, A03, A04, the final project, and probably even A06, there's been some form of extra credit, right, on the assignments. So all of that will help to balance this out. So I wouldn't worry about it too much there. So next Thursday we have that. It's the same format kind of as the previous one. You have the full 75 minutes to take it. You may not have to use it though, so we'll see. And then some notes here. So Oriole is due Friday. Also, I want to clarify because someone asked a good question about this, the late period. When I say there's 3 free late drops, it's not just 72 hours. It is literally 3 full. So you can submit 3 assignments 2 days late, and that will be all dropped. So it's not just 72 hours. It's kind of the full late period you're allowed to use. And so that is all there. The late period is still here. So feel free to use it if you wish for this particular assignment. Given the way that the schedule is working, we'll be talking about final projects as well, actually, at the end of class and what that will look like. Given kind of the way that everything is moving in this semester, it would be very hard to kind of move this due date along because it will truncate the time for remaining assignments and make that one more difficult. So we're kind of trying to balance it all out here. This assignment's been open for 2 weeks, a bit longer. I think 6 days longer than last semester. So yeah, question. It should be, I will double check their details. I'll show the details afterwards. Yep. Great. And then another note here, just for those, so to kind of help out here, there was a dozen or so missing pre-reading submissions. I've just gone ahead and reopened it. So if you didn't submit yet, please go ahead and do so. That way you don't have to worry about those 5 points. Any other questions here so far? Great. All right. So again, thank you for your good work so far throughout the semester. I know it's been a lot, but we're getting to a point where we're being able to build really exciting large-scale applications down this class. We're doing Oriole. Our next assignment, we'll see the same thing, and we'll be building up to final projects, which will be really cool to see. All right, so again, and kind of I already mentioned that as well. Remember about the late drops. So again, this is the last day kind of the backend module before the exam. I will note though, today's content is not on the exam. That was already, I think, mentioned last week, but just to be sure there. So we're rounding out the module, and we have been discussing kind of a lot about infrastructure features, right? Backend infrastructure that helps us to power our web applications. We started talking about databases. Databases help us to store actual data for our applications, have that data persist between, for example, different times a user logs in or on different devices, that we're able to access this shared resource of data all in a database. We also kind of talked about ORMs and how we can interact with a database using a tool like that. Authentication, we talked about keeping track of users, right? Making sure that maybe if certain resources or certain API routes are protected, there is authentication as a layer, which allows to make sure that only those that you want or those who have signed in are able to access their own resources. We talked about storage. So how do we actually keep track of user uploaded files, for example, images, or even other types of files as well? You're using this in Oriole for uploading profile images as well as post images. So we've talked about storage. And then finally, we have talked about real time. So using WebSockets, that's what we did last lecture, to essentially enable these real-time updates in our applications. So for example, remember there are three main types of real-time that we talked about last time with Supabase. One is just broadcasting a message to everybody. Another, listening to a database change. And so in real time, if a row in a database changes, it's streamed down to the different clients. And then finally, presence. Who is all online at the same time? So with that, we just have a bunch of different devices connecting to the server with a WebSocket. That allows us to keep track of who is actually online currently and who is not. Any questions here so far? Perfect. And so familiarity with all of these classes of tools is very, very important. And it is used in all of these large-scale production web applications, right? So both in maybe personal projects that you might want to work on, but also in industry as well. If you go and work for a company, you will see a lot of these, if not all of these things, in large-scale applications. Okay? Now, more recently speaking, this is kind of in the last 3-ish years at this point, maybe a little bit more, but around there, another class of technology has become very prevalent, and a lot of developers are having to end up using this type of backend tool in order to power certain features in their applications. And that is, of course, generative AI, right? These AI systems. So generative AI has been, again, something that a lot of different applications are trying to implement in some way, maybe some features that help the user, et cetera. And so it has unlocked a large set of new possible features for applications. A lot of text-based operations before would have been very difficult, require a lot of advanced natural language processing, machine learning models that developers would have to build. But now with these general purpose generative AI tools, working with text data has become very easy, and the possibilities of what you can do with that type of data is endless. And so companies across all different sectors, right, not just the tech industry, other industries as well, have been racing to use and adopt these particular features in applications that they use. Right? So it's not just, we think of kind of the most common, maybe bots and chatbots that we see, or maybe certain apps like I would assume, right, Zillow, for example, which is a house shopping real estate app. They have generative AI now, there's all these different features, but also other applications, for example, internal applications used for inventory management in large companies, or perhaps agricultural applications. There's a lot of these software that they're building in various sectors. All of them are utilizing these systems. And so it's important to understand how to use these. In addition, another key thing, if you talk to career services in our department, they have stressed this as well to a lot of us as instructors, is that companies are, for better or worse, right, they are expecting a lot of their new hires to have some sort of experience or some sort of knowledge using these tools, because a lot of the features that they're implementing currently and that they're hiring for often use some of these systems. And so it is important for curriculums like F'25 and others to kind of introduce this in a way that makes sense so that you all have real-world practice with these tools, right? And so in F'25, we have a unique opportunity to show how we can actually integrate these particular systems as features in our applications. And because we've been building these full-stack applications, we've been talking about using these different back-end infrastructure systems like databases and storage and WebSockets, and generative AI is just another category in that bucket. But it's also important for us, right, to stress important considerations and pitfalls when using technology like this. It's new technology, and there are a lot of cases where you may have very unexpected results when you're working with something like this. And we'll see kind of what that all means and how in a moment. And also, it's very important to develop a bit of an understanding of how these tools actually work, because we think of generative AI oftentimes as something that is kind of this magical all-knowing entity that you ask a question, it spits out the correct answer, but that kind of loses a bit of understanding of how these things behind the scenes actually work and what you should expect when you get some results from that. Okay? Questions so far? Great. So generative AI, we'll start with a bit of a definition here, right? So it is just any system, it generates new content, right? So that's the generative word here. We are generating new content, whether that be text, some cases images, and even video recently, right? Based off of some user prompt, some input into the system, right? You have some sort of model, which I'm representing here as kind of a box. This model is what takes our input, the user input, which is maybe this prompt, and then generates some new content as output, right? So we have some input prompt. Maybe that's a question if you're asking Gemini or ChatGPT a question. And then what it ends up spitting out to you at the other side is this new content that was based on the prompt that was already provided, right? And so a lot of times, right, we often treat generative AI tools as kind of this black box, right? It's like this magical tool that just does these things, and we don't really have to think about what goes on inside. And that oftentimes ends up reinforcing a lot of misconceptions on how these tools actually work and what they're really doing behind the scenes when you ask a question, for example, and then it prints out some response to you, right? And so this, as I've already mentioned before, it leads to also incorrect expectations. So if you're not really familiar with how these tools work, what you may expect as an output and what you may expect from this model may end up being a bit different than what you actually end up getting, right? And so the key thing here is, of course, generative AI is not magic, right? Otherwise, it wouldn't exist, and we wouldn't have these systems in place. And so modern generative AI tools like ChatGPT utilize these models called large language models, something you have definitely heard of at this point. Stands for it's acronymed as LLM, right? To generate responses and create new content based on some input prompt. And so all an LLM is another kind of a definition here. It's just an algorithm, right? So it's an algorithm that performs a large variety of these natural language processing tasks, right? Because we're working with language, real language as input and output, right? So we're working with natural language, and it allows us to do different things: recognize, maybe translate, and predict and generate, of course, new text based on some provided prompt. The word large here is emphasized because these models, this algorithm, has been built around and trained on very large, astronomically large data sets. When I say astronomically large, literally almost all of the text data on the internet, in books, in physical media have all been inputted in to these models to try and train them to give the best output for a prompt. And these algorithms simply extract meaning, right, from some sequence of text by understanding the relationship between words and phrases within that particular input. So we're using algorithms to figure out kind of these relationships. LLMs are not the only thing. We also have things like LVMs, large vision models. There's various other things as well. Models that work with kind of generating different types of content, not just text. You have images, you have videos. For example, I think Sora was what was recently, there was some release of that where people are making AI-generated videos, right? That is also an algorithm, except the output there is not text, it's actually some video, right? Any questions so far? Yeah? How clear that Mr. Futures doesn't use an API? Good question. So It's very common that, so you're saying like the main providers, right, that we have like OpenAI, most of the companies are using those models because those models are trained on the most amount of data. There are some cases internally, some companies may try to train their own model, meaning use their own specific input, or they might kind of pass their input into a maybe enterprise version of for example, OpenAI's model or Anthropic's model. But I would say a lot of the apps end up using those main providers. Yep. It's kind of the same situation, right, with AWS and with Azure and other things. As we talked about, we end up having a very small amount of tools with a lot of usage because these particular companies have done a very good job with training these things. So what I want to talk about here is how LLMs actually work and what happens behind the scenes when you ask a question. Because what it ends up doing every single time is a bit maybe a little bit surprising to think about. All the main kind of what ultimately LLMs are doing is we take some number of tokens. We're going to talk about what a token is in a moment. We pass it in to the language model algorithm, and we simply generate another token. Right? So what we're doing, we're taking in a sequence of tokens, and we're generating one new one that we're predicting is going to be the most likely next token. What is a token is a good question to start with here. So all a token is, it is just a unit or chunk of text that is used by these type of models. They're usually typically, so short words, for example here, right, is so cool are often their own tokens. Larger words may be split up into multiple tokens depending on meaning. So typically these tokens are maybe similar in linguistics to like a lexeme, right? So it's a unit of meaning. Oftentimes punctuation is also used as its own token, right? So there's a link here that I think would be interesting. So if you have this link, you can click on it. This is a token visualizer. And what it allows us to do is see how text is often split up into different tokens. This website is a little bit older, as you can see, because we do not have kind of GPT-5 and Gemini. But if I use GPT's 4 model, I can type in some text in here, right, like hello world, welcome to Comp 426. And you can see here what is, I'm not sure why that's there, but you can kind of see that our text that we type in is ultimately split up into these tokens. So you can see here that 33 characters of text is split into 9 tokens. These tokens are a kind of our base building block, our base measurement of text when it comes to a large language model. You'll often see, and we'll talk about later as well, they sometimes charge based on number of tokens generated. And so token is kind of that key, it's like that unit of measurement that a lot of these companies end up using when it comes to kind of quantifying input and output to a model. Right? So you can see here we have where every single word was its own token. But again, if I do something like, right, generative AI is so cool, right, we end up splitting one word into multiple tokens. So it is possible. And this is based off of, again, some meaning, length, et cetera, that ends up determining how this is separated. You can also press show example. And here's a very long example and showing how this particular paragraph here is split into 96 individual tokens. Right? So you can see here, there's also some description, right? A token, piece of text that a model reads at once. All right? Questions so far about tokens? Yes?
Based on the amount of tokens they generate, like the answer.
Yes.
So, like really like long answers, like is there like any motivation for them to give you like concise, good information?
Good question. I do suppose that could be exploited. I think though, a lot of times though, when you have large, not only is it pricing, the reason also they charge is because there's a lot of computational load. So even if they're generating really long responses, then it might prevent them. It ends up increasing the amount of energy that they're using, and end up maybe preventing other people from using it. And of course, the entire thing of competition, if one provider is not doing it and another is, everyone would go and use the provider that has better pricing. And so it's kind of all of those things come into play to kind of keep it level. But good question. Yeah.
Do they algorithmically decide when a word is broken up, or is that done by humans?
Yes, so this is all done algorithmically, I believe. And actually, a good thing to note here is depending on the model, so models may have different ways of doing this. So you can see that by switching to Llama, for example, our tokens went from 96 to 105 because they provide other things. So like you can see the word tokens was split into two. With this Llama model, with GPT, it was one single token. So it really depends on the model and the methodology that they use. Yep. Good questions. All right. So that is kind of that helps us to describe what tokens ultimately are, right? So they're just these units of text. And there we go. And so again, when we talk about this idea of how large language models work, text generation happens simply by we take a certain number of input tokens here, and our model will then predict what should be the most likely next token to follow the input. So if we have 4 as input, the model is going to figure out what should be the 5th token based on what has been provided before it, right? So a visualization of this that might be helpful is something like this. So you can see here that let's say we have the sentence, right, keep calm and carry on as kind of our baseline. We pass in keep calm and carry 4 different tokens into our model. The model is going to produce something like this, where we have some sort of probability to a list of tokens. So in this case, this is artificially done. So this is not based on any particular model. This is just something I've kind of drawn as an example. But you can see that we'd have probabilities associated with next tokens, and the model will choose one of the most likely tokens that should be the next one. So here you can see, in this case, I've said that maybe there's a 72% chance probability that on is the correct next token, and that's the one that we should return. And the model will select that token and simply generate one token back, right? Now, you're probably wondering that, well, aren't responses a lot longer? It's not like generative AI models just give you back one single token, right? And so how this works, this is an iterative process. So the way that the models end up creating a long response is simply performing this over and over again. We start with one token, we generate the next one. Then we take the input and output, we concatenate it together, we pass it through the algorithm, we get back a next token. And we repeat this all the way until at the end, it would output some end token, which says that this should be the end. We're not going to continue generating more. And then what you're left with at the end is a stream of tokens that is your response, right? So for example, when you type something into ChatGPT and you press enter, right, it's kind of writing out as it's going. This is what it's doing. It's calculating what the next token should be at every step. And then at the end, you have a completed response after the model is done running, right? Yes. Good question. So this would be based on, and I should have included it here, there would be some prompt. So the user would maybe ask a question, and then that would be used as kind of the first many tokens. And then from there, it would generate more. Yep. Good question. Any other questions here? All right. So again, large language models. And when I say large language models here, this is the standard model. So you might be thinking of reasoning models, which perform ultimately the same thing, but it does it a little bit differently, where those are like, I think, GPT-5, or I think there's like O1 or something. I forget what the terminology is. One of those are what they call reasoning models, where it kind of is spinning its thinking, in quotes, right, before it ends up producing a response. And all that does is actually just behind the scenes creating a bunch of notes to itself before it ends up giving an answer. So it's essentially giving more tokens as input so that it kind of gets, it tries to work through the answer. You might have multiple of these running before it chooses what the best stream would be, right? So reasoning models are a lot more sophisticated than our traditional kind of regular fast AI models that we use, but there's a lot of proprietary algorithms that end up going into that, right? And so LLMs generate text token by token. Every time they are determining what the probability should be of the, or what token has the highest probability of ultimately showing up next, and that's the one that it ends up choosing. And so these probability distributions, where, for example, we have 4 tokens as an input, we have some distribution where we have all these probabilities next to tokens, right? This is the unique property of the model. So this is why asking different models, different questions will maybe get different responses because these models are trained differently. So these probabilities that we kind of mentioned here, right, these probabilities are determined based on the training that the model ends up going through. So for example, there's been a long-running, and I haven't looked at any benchmarks recently, but the long-running assumption, for example, has been that the Claude AI model has been the best at coding and programming. And that is possibly because when they were training this model, they ended up passing more potentially programming, more code into the training. They may have spent more, they may have weighted it slightly more to that input. And therefore, the probability model that it got back ended up being more correct. Right? And so this is all dependent on how specific models are trained by whoever trains the model. Right? Let's go back here. Another thing to note, which you might be wondering, is, okay, right, Jay, if we have something like this, and I'm saying that we have some top probability of that we have generated, well then if I ask the exact same question to the AI model, why do I get different responses every time, right? Because if we're just choosing the best probability every time, why are our outputs different, right, and vary? And there's an internal kind of metric here or parameter called temperature that these models have. And temperature essentially is what is kind of denoting maybe what the word we would say here is creativity, right? Or how much variation can we have with different runs of the exact same prompt, right? So what'll end up happening is maybe the top ranked token is not chosen every time. It might choose one of maybe the top 10, top 5, et cetera, every time to get some variation into the actual response. And so there's a great link. I highly recommend opening this up. It's called this Google AI Studio. And if you open this particular link, there is a good amount of information here. I don't know what Nano Banana is, but maybe that's an image generation model. This looks new from the last time I opened this, but there you go. So that's another model to play around with. You'll see on the side that we have actually a temperature knob here. The AI Studio is very nice because we can ask different questions and we can kind of see what our output is, right? So for example, I'm going to ask a question here. In one sentence, explain server-side rendering, right? And I run this model. So this is using, I believe this is set to, I'm not sure, what model is this? Well, let's see, we'll run it, right? So we get some response from our model, right? So it says, is a technique that renders a client-side JavaScript application on the server and sends a fully rendered page to the browser, right? So this is something we talked about. If I were to ask this exact same question again, though, right? So let me paste this in, right? Actually, here we're getting the exact same thing, I believe. If I maybe made like 3 sentences, so in 3 sentences, explain server-side rendering. I ended up with something larger here. And let me see if I copy and paste this again, if I get a different response, because typically you would. So let's run this, unless there's some seed that's set, but this should be. I think this website is, wow, OK. I think we're having some technical difficulties here with pasting this in. But there we go, right? So these actually do look the same to me. So it's possible that when they set this, Typically what you do and what this example would show is and this worked before, but you would set your temperature to 0 and you would run these particular questions and you would you'd always get the same result back. It's very possible though that given this particular setup here, they may have some sort of seed set. So if it's essentially using the same randomized, it's using the same settings every time. I would recommend, though, playing around with this. Typically, this temperature ranking, as you can kind of see here, when you highlight over, right, they call it creativity allowed in responses. When your temperature is set to 0 every time, and if we tried this with a different model, it would probably work. You should get the exact same output every single time. With your temperature much higher, like set more towards 1, you should ultimately get kind of the same, or you'd get different responses every time. So during the break that we'll have coming up, I'll see if I can get a proper example working here with Google's AI Studio. But I recommend trying this out as well. And you can use, I believe, even OpenAI may have certain kind of settings that you can play around with. So I'll see if I can show that later. But again, Google's AI Studio and other tools like this are a great way to play around with different metrics. So if you can see, there's even advanced settings here. You can see here's another one, right, where we have probability threshold. So this might be saying that what are the tokens, right? We have probability of what the next token should be. Let's select a certain range of which tokens to allow. And so this is a pretty nice tool to use. Any questions here so far? All right. So one thing that I'd like you to spend some time on here is to think about what might happen or what problems may arise if, assuming now that we know how these models actually work, where they're generating just one token at a time every single time. Maybe we're choosing a kind of a random token from a top certain range of best tokens. Well, what problem may arise with this particular approach when it comes to the output that we end up receiving? So we'll spend a few minutes on this, and then we'll come back together and discuss. All right, everyone. Thoughts on this particular question here? Got very, very quiet all of a sudden. Any? Yeah.
It's like be wrong on purpose because I guess temperature can make a difference.
Yeah, exactly. Yeah. So that is the main thing there. You could choose a wrong token, and then if you choose the wrong token, your response would be incorrect. We wanted to add, yeah. Might be like really small. Mm-hmm. One really small begin of another small, and then it's not. Exactly. Yep. So all of these, the problem here, right, is kind of this idea that one wrong mistake somewhere can propagate and become a much large. We can have a very, very large divergence from what the correct answer should be if anywhere along the line one token is chosen incorrectly. Or, for example, maybe if our temperature is too small, and then we get kind of pigeonholed into an answer that is not actually correct. Right? So this is where this terminology of, which you've probably also heard of in the age of AI, right? This idea of hallucinations. So LLMs can very easily and very confidently, might I add, so this is a very important thing to be aware of, hallucinate. The idea in whenever hallucination, this terminology, is essentially just describing when an LLM chooses the wrong next token somewhere in this in your output generation. Right? So the LLM's prediction for what the next best token should be ends up being wrong. And this can throw off, right, an entire response. Because if just one next token is chosen incorrectly, that wrong next token is then used as input for the next token and the next token, like so. Yeah. Yes, so this is how a majority of our kind of the regular models work. Those reasoning models, as I was mentioning, the ones that kind of stop and think through, there's more iterations and more things that happens behind the scenes. Yep. So this can be visualized, right? Something like this. So let's say that I'm trying to generate, you probably know what I'm trying to generate here, right? The the quick brown fox jumps over the lazy dog. Let's say somewhere along the line, right, like right here, we end up choosing the wrong token, right? Once we choose that wrong token is then added as input for the next generation. And this may generate a new token that is now based on the wrong input token. And we just continue adding more and more incorrect tokens, right? So it takes any of these tokens anywhere along the line in your response for one token to be chosen incorrectly may end up causing a very big deviation, right? We didn't just get something like the quick brown fox bought the lazy dog, right? We didn't get that. We ended up generating something that fits more, right? Bought the new video game fits a lot more with that word bought, right? Because that was a token that was used as input. So you can see a very big divergence from what we may have expected as the correct answer. Right, so one incorrect token can essentially corrupt the rest of the response and cause it to what we call hallucinate, right, where it just produces the wrong answer. And you can see here what that difference might end up looking like. Now, it's very important to note here because, and actually I have this on the next slide, most of these models cannot detect, right, when they have hallucinated. There are some cases where you may ask certain more autonomous AI, for example, they call these agents, which are just like these self-running AI systems, where they might look at the previous response that they generated and then run that through, like, was this correct? And then they may say, whoops, sorry, I said something wrong. Most of the time, though, there's never a kind of like this, when you ask a question in ChatGPT and it produces a response, you don't often get a correction response after the fact saying, actually, what I generated was wrong. Right? So they cannot often detect or alert the user when they have hallucinated. And so the ultimate TLDR of this is that models will behave as though they are very confidently correct, right? Because they output an answer. When you talk to a human, you may be able to get some intuition, right? If somebody doesn't know what they're talking about or is kind of saying the wrong thing, right? A human may kind of stutter a bit. They may be, I'm not fully sure, but, right, et cetera. That's kind of what a human does. A model is just going to answer the question and move on without any regard for whether it's correct or not. Right? So, and that is, again, because of the way that it works, where we're just generating, right? All of these things ultimately just come down to generating the next token every single time. And so whenever you are using AI tools or models or anything, you cannot just directly trust always what it is saying. There have been many cases where in the past, especially in the beginning, where there can actually be very dangerous implications for something like this, where people rely on models, for example, for medical advice, cases where people rely on these models for example, there's been cases where people are using it kind of for therapy and advice for social settings and interaction, right? And these are just not necessarily things that you may want to trust an AI model's word on how to, on what it says. You may not want to trust that, right? So this is, again, even though these models seem like they are always kind of this clairvoyant thing that is giving you the right answer, all that's happening behind the scenes is just it's choosing tokens based on probabilities, based on an algorithm. And so that if that model is either trained poorly or it's not seen something like that before, it could very easily select the wrong thing. And so it's very important to kind of be aware of that when using these type of things. Any questions here? Oh, yeah.
Like temperature value, but
Mhm.
not picking like the most comical next word
Mhm.
is increasing a rate of hallucination or potentially increasing more hallucinations, or do you think it's actually compensating?
It could, and it could do both. So it's very possible, right? And I could actually kind of draw, because this is what, I believe someone in the front row was talking about this, is where, let me grab, right? Let's say if we have some sort of graph, and this is a very poor visualization, so I apologize here. But you can imagine that if we have some graph and then maybe green is like what our correct answer would be, maybe based on some probability. What could very well happen is if you're constantly choosing the best tokens, you may end up getting somewhere, and I'm not really sure how I'm going to visualize this too well, but if you're choosing maybe all of the best tokens all the time, you may end up kind of pigeonholing yourself into whatever it thinks was the best or whatever the best probability was. It's very possible because when you have no temperature, right, there's no variation. It's always going to select the same thing. But if that same thing that it produces is incorrect, then you actually may have more hallucination. Because if the range of correct answers, like let's say maybe a better way of describing this here than how I've drawn, whoops, is like, let me erase. Erase. There we go. Maybe we have some range of correct answers, which looks something like this. Right? We have some range. And the best answer where you choose with a temperature maybe of 0, where it chooses the same answer all the time, could be like up here, where it's not actually in the range. And so if you choose something with, maybe we don't choose the best token every time, maybe some is like we choose 90% probability or slightly less, maybe we end up somewhere in the correct range, right? So it's kind of, you can pigeonhole yourself if you don't have any variation. And again, if you have too much variation, then you could also kind of get out of that range. So these are all things that are very important to kind of consider, and different models. So that's the reason why models have variation in them, like this temperature value. Some people can kind of tune that depending on maybe a type of question that they're trying to answer. Yep, very good question. Any other questions here? All right. There are many models, and many of you have probably tried many of these throughout your time recently, right? So many different models to complete different tasks. Right? You have GPT, which is OpenAI's model. This is the one that that really brought this to everybody's kind of minds recently. Gemini from Google. Gemini is very good because, and we'll talk about, they have a pretty good free tier, and they have very good pricing. Also, probably because Google is an extremely large company where they can afford to undercut and try and maybe even lose money just to beat the competition, right? So that's the reason why Google's models are pretty cheap. And then Claude, which is one from Anthropic, very popular models, especially amongst developers, because Claude has been is pretty good. It's typically, in the past at least, according to benchmarks, has been the best for actual generating code. And I will say anecdotally, whenever I work in programming languages or ask a question in a language that's not necessarily mainstream, so for example, right, Python, TypeScript, JavaScript, very mainstream. Most of the models do a very good job with it. But if you are, and if any of you are in an app team, you might know, right, Swift for iOS is one where actually a lot of times when you ask GPT or Gemini, it will give you it's more likely, at least in my experience, to give you the wrong answer than something like Claude. If maybe Elixir, for example, in real time, if you're working with that, definitely you may experience some issues, right? So also the quality, right, depends on how much code has been publicly scraped, right, by these companies. And there's so much open source, free Python, TypeScript projects that it can read and use to train the models, but a lot of apps are closed source. And so maybe the Swift language, there aren't as many examples out there, and therefore it's less confident on getting those answers right. But again, that's a bit of a digression, right? There's all these different models that we can choose from. And kind of as was mentioned on the left-hand side here at some point, right? These companies, Google, OpenAI, Anthropic, allow developers to use their models to generate content. You can call an API, and you can pass some input into the model, and then you get some input, or you get some output back, kind of in the same API type format, where you would make a request to the, let's say, OpenAI server. That server would have the model running on it. It would generate a response and then send it back as a response, right? So kind of a similar model to what we have talked about before. And again, as I mentioned at some point, right, this is typically expensive. If you're building an application that is used by thousands of people, and thousands of people are using this AI feature, all of those requests are going through these servers, and it ends up amassing to a very large amount of usage, right? And so they will charge, these companies will charge based off of usage, often by number of generated tokens, right? So tokens are kind of that building block, that unit that they use to measure. Good news is for you all, through and big courtesy to UNC, which has spent a lot of, they have an entire part of ITS now that is dedicated to essentially giving tokens out. You will have free access for features in this class to the OpenAI, to these OpenAI servers to generate responses for features in your project. So in your final project, you'll have a chance to use this. So courtesy of UNC, everyone will have access to this. And there'll be more details about how to use it. But that is something that you won't have to worry about in this class kind of usage. You will be able to, at least that's what they've told me. And maybe if somebody overshoots, they'll send me an email. But I don't think anyone will reach that point where you overuse these. So you'll be able to use these in your projects and actually use these models for features. Now, the question I have is, how does this work in the context, right, of our diagram? Our very, very famous diagram at this point that all of you, if you've been maybe reviewing for the exam, you've seen, right? We have three different parts. This is our three-tier architecture that we've been talking about. We have the client side over here, the front end. We have the server side, the back end here, and then you also have some data server. So for your projects, this is the setup. For example, with Oriole, this is what it looks like. You have your React Next app, right, that runs whenever a user goes to your page. You have some server here. You also have Drizzle, right, which is sitting on this side for querying the database that you have seen. And then we have Supabase, which provides us a database, and it provides us cloud object storage. So you can have uploaded files in there, right? So we can now add another example, right? Again, all of these things that we're working with, these are all servers. And we are all communicating between these different servers and clients whenever we're building these types of apps, right? So maybe here we have OpenAI server where GPT-5, let's say is the current model, is running. And we can then make requests to this model so that when a user, let's say there's a chatbot feature in your website, when they ask a question, that question can be sent over to OpenAI, and then OpenAI can give a response. My question that I want you to think about for the next 3 or so minutes is, which part of this diagram of these three options, here, here, and here, ends up actually connecting to the OpenAI server? So if I were to draw an arrow, like I have 2 arrows already, where would I draw the third arrow? Between what 2 boxes here to connect to the OpenAI server? So spend 2 to 3 minutes on this, and then we'll come and discuss it from here. So think about this. All right, everyone. I think people have gotten a bit quieter now. Any thoughts? Actually, let's do it, because I think fishing for one volunteer will be difficult. So raise of hands, you think the client would connect directly? All right, raise of hands if you think the server would connect directly. Great. And then Supabase. All right, great. So you all are correct. The arrow would end up going right between the server side here and OpenAI, like so. The reason is because, again, just like with our database, it's the same problem, is that whenever we're given, whenever we contact OpenAI's server, right, we have they give us some sort of API key, some essentially password to be able to use that service. And if we had the client directly contacting the server, well, the ability to contact the OpenAI server would be leaked as part of that JavaScript that ultimately ends up on the client side, right? So when we fetch all the JavaScript down, okay, so the arrow here I'm drawing is a hypothetical. If we had some sort of arrow like so, that means that sitting on the client, there's some JavaScript code that's able to access this server, which could be abused, right? If someone found that out, they can just hijack it and copy that code and use essentially your payment plan to do whatever they want, which is not good, right? So very good question, a very good thing here. Now, one thing I will note, and this is not something that we're necessarily going to, at least I don't think so, but we'll see in the next assignment, maybe. But one thing I want you to think about is, in an app like like ChatGPT, you see tokens appearing one by one, right? So as you talk, it's like writing it out line by line. It's not just you ask a question, you wait a few seconds, and then the entire text blob appears there, right? So how do you think we might be able, if we wanted to, let's say, recreate ChatGPT, how might we be able to have that text kind of streaming in as it is generated? I know you said it. I want you to say it out loud, everyone. WebSocket, exactly. So this is an example of a connection to what we talked about last time, right? So if we have a connection, and thank you, by the way, I appreciate it. So, right, we have some sort of arrow from here to here. And let's say we make a request. Our clients makes a request that here is my prompt, or here's my message, right? Generate some prompt based on this. We can have an open WebSocket connection from here to here. And we can then stream as tokens are generated, and we can just put it down the socket so that we end up getting a response nicely streaming in kind of word by word, right? So I don't know if that's going to be in the next assignment or not. I guess we'll find out together by the end of this week. But that is something that these are how these applications work. There are also other techniques that are used for the streaming that certain apps may adopt to use, but using what we learned, great connection to what we already talked about and how WebSockets and why they're so useful. Great. So again, correct, there's an arrow here. For the same reason, right, our server will connect directly to OpenAI. We don't want to expose our API key. So perfect there. Now, another note here is how do we structure our requests? So there's this terminology that's been used recently to kind of describe what all this is, right? So whenever you communicate with GPT, even from our server, so if our server is making a request to GPT, we have to provide along with it what's called a prompt, right? A prompt is just that text. It's that input that you pass into the model before we get some output back, right? These responses are text-based, and I think here, yes, I think this should say the prompt is text-based, not the response. I'll update this, right? The prompt is text-based, and so it is up to the developer ultimately, right? As we pass in different prompts, depending on how we write that prompt, we may get different responses back. And so if we want to have kind of a response that fits in a structure that we expect as a developer, then it is up to us to write a good prompt to the model so that the model gives us a structured output that we want. And so there's this terminology. Who knows if it'll stick around? This is the terminology that I think is currently floating around, right? Prompt engineering, that's the fancy term for this. This is essentially just describing, right, how do we write a good prompt to a model so that we get a kind of a reasonable expected response back. Writing good prompts is essential. And in fact, the trade secret, frankly, of a lot of these AI wrapper type of apps that are out there today is literally just writing this prompt in itself, because you can technically replicate a lot of the AI apps that exist out there today. The only thing that they may have data, and then they also have some prompt, right? This is a prompt that is their secret prompt that they use to kind of power their application, because ultimately, again, every time we send something to this AI model, we're just sending along a prompt. And so good prompts can lead to good results. And a lot of the apps that you use, right, under the hood, they claim that these are all, AI is, we're AI-powered AI app. A lot of times that just means calling as someone was mentioning, right, calling a API to one of these models with some prompt with your data in it, and then it comes back with a result. That is ultimately what a lot of this ends up being. It's nothing too special under the hood, right? These prompts, though, need to be written well in order for these things to work reliably. And so there's a link here that I think is good to maybe reference, is kind of from on OpenAI's website. They have details about kind of how or what are good models or good things to kind of keep in mind of when writing prompts for the model, right? For example, put instructions right at the beginning of the prompt and use, for example, these triple quotes. Sometimes you see triple backticks. to separate like some content, right, from an instruction. So for example, instead of just saying, here is my, and I hope that this is not happening too widely, but here is my app. I'm working on this in 426. I'm having trouble, right? And then you copy paste your code in there. Well, if you want a better response from the model, you might want to format it where you have, and I'm not sure why I'm giving instructions for this, because this is this is not what we want, but you might want to separate that code with some sort of delimiter, right? Like some quotes or some backticks, so that the model knows, well, code has started. It's not just talking about, it's not just your instruction anymore, right? So that's something that might be important. Adding more details about what you want as a result, what the format should be, how long a format should be, the style, right? So for example, this, right? Desired format. So extract the entities mentioned in the text below. Maybe this is trying to get details about a company, right? And some people at a company. That's maybe an example of the bad prompt. And then here's an example of a good prompt, or we have a prompt, and then we write here desired format, and then we supply a format to actually that the model will use to kind of follow, right? And let's see, there's some other things here. Reduce fluffy and imprecise descriptions. So for example, instead of just saying, right, should be fairly short, few sentences, not too much more, actually use a real like 3 to 5 sentences, write that out, right? And so there's also this is actually interesting. I did not know. So for example, code generation. So use the leading words to nudge the model toward a particular pattern. So you'll notice here that it's recommending us to actually start our Python code with a word like import, and then it will, because again, remember, we're generating new tokens based on the input. So if we pass in import, or we start writing Python code in our input to the model, then it's more likely the next tokens that will be chosen is actual Python code. So this is another thing that we can use. Any questions here? And here's another note about temperature, right? So a measure of how often the model outputs a less likely token, right? So the higher the temperature, the more creative. Not the same as truthfulness. That goes back to kind of that point, right? Is that selecting a temperature of 0 does not mean what it's saying is necessarily more truthful. There are some cases in these models you might want to set the temperature to 0. Looks like Zoom's not connecting anymore, but I'll be recording another video. I'll stitch them together. Does anyone have a prompt that they might want to share that is better than the one that, maybe the one that we provided here? I'm sure that whatever you wrote is better than what's on the board, so don't feel too, let's see. Anyone? Yes. Thank you. Okay.
Still a little fluffy, but and then at the very end, say, here's my essay with the triple quotes in the text.
Perfect. Yeah, exactly. That's perfect. There's various different ways of going about this. So amazing work. Anything like that is good. I'll show you what I have here. I hid it this time so that you didn't have access. Something like this, right? So here is my essay draft denoted within triple backticks. You have essay, you have your delimiter, and it says do the following. 1, improve grammar and clarity. 2, expand each paragraph by 2 to 3 sentences. 3, adjust the tone to be moderately formal, like an academic essay for high school, right? Very specific. 4, return the revised essay as full text, right? Is the output of what it should be. So this is an example of maybe one way that you might write a better prompt, but there's various ways of doing so. Okay, so make sure that you have some submission on Gradescope for that. And it should be fixed now, so you should be able to submit both things. I forgot about this real quick. There are also details. So one thing you might wonder is, if I ask a question to an AI model in my code, how do I make sure that, let's say I want to produce, let's say it's like I want to generate flashcards based off of some input that a user puts in, like some slides. I want my output to be an array of flashcard objects, right? How do I kind of bridge that gap between the text-based output of an LLM and an actual object in our code? There are ways to go about doing this. And there's actually, I believe, there is something in here, if I remember, in this example that I linked here. But I'm trying to find it. We have prompted structured outputs. This is what it is. So you can, for example, do something like this, where we have a model here that we've provided. So this is using a package called Pydantic. So all it is just creating some sort of like representation of an object for a calendar event, and then we can supply it in here as the format of what we expect at the end, and we can parse the output. And in the end, your output event object in, for example, Python here would actually be a object. So this is a nice way, and there's various programming languages have something like this. All right, so before we get too carried away, with 3 minutes left, I want to go over some details here. So final project details. We have around 4 weeks left now. I know it's hard to believe, but we're racing towards the end of the semester. I'm having a hard time with this as well, with believing that, but it's there. You can check the calendar. We're getting there, right? So what we have right now, I will say ahead of time, there's 2 more coding assignments. One is larger than the other. So A06 alias, that's going to be recreating essentially Discord using all of the tools that we have used, or like Slack with WebSockets, etc. That'll be that assignment. And then A07 is smaller. It's just a design lab. So you'll be playing around with building nice user interfaces. No more readings. Everyone's very happy about that, I'm sure. And then 2 modules left after the midterm, our design module and kind of a expanded technologies module at the end there. And then some note here. So I will say that there will be teams of 4 for final projects. We are going to have a form that we're going to send out. So if you already have a team or you have people you want to work with, totally good. If not, also fine. You can submit information about there's information about your working style, availability, maybe an interest in a project. And I will do my best to match together all of these various factors to create teams that hopefully will work out well. So I think given that we have 1 minute left, I think it'll be best to maybe continue this part after the midterm, but there is a document here with different information about what the project will end up looking like, the grading criteria, details, all of that. So we'll talk about this next time. See you all later. Best of luck. Don't stress on the midterm. And if you have any questions, let me know. We'll see you on Thursday.